All right, so elements can have all kinds of common oxidation numbers, but if you kind of want to see what they are, you can go to the good periodic table, the ptable.com. Up top on this tab, hit this electrons button, and then you'll see what happens to all your elements. They have all of these numbers underneath them. Those are their common oxidation states. And a lot of times, a lot of the oxidation states make sense. They don't always make sense, but a lot of the times they do. For example, nitrogen. If we think about nitrogen, it's got 2 electrons in its 2s orbital. And then in the 2p orbital, it's also got 3 electrons. So when we're at this -3 charge, we basically just remove all p electrons. And that makes sense. They're higher level or higher energy electrons. Oh, my bad. The +3, not the -3, the +3. So that makes sense that we would remove them. If we have the -3, that's 3 additional electrons. So in that case, we have a filled octet. So that makes sense why it would want to have that -3 oxidation state. And then for this +5 oxidation state, what happens there is it loses all valence electrons. Right, so we wouldn't expect nitrogen to be able to have an oxidation state of greater than 5 because it only has 5 valence electrons. So again, oxidation states are just another way of counting electrons, keeping track of where they're going, talking about electron density.